Hi everyone. In continuation to previous video, three-phase induction motor construction, we'll continue with the next topic, which is rotating magnetic field theory, which is related to three-phase induction motor. It is very important to understand the theory, rotating magnetic field theory, because it helps you to know about the working of three-phase induction motor. So let us continue with this topic. So as I said you, this is the stator, and stator has windings, which has three-phase windings, which has been discussed in the construction of the three-phase motor. So what actually happens? So whenever this is the three-phase and there are poles, and whenever we give three-phase supply is like this, and we give three-phase supply to this line 1, line 2, and line 3 to the stator windings of the induction motor. So because the supply is three-phase, we also get three-phase flux like this, which is again a three-phase waveform. The equations for the three-phase waveform are phi is equal to phi m into sine omega t, phi y is equal to phi m into sine omega t minus 120 degrees, phi b is equal to phi m into sine omega t minus 240 degrees, or it is written as plus 120 degrees. You can see here they are equal in magnitude actually, but displaced by 120 degrees, which is written in the form of polar wave like this, phi r, phi y, and phi b. And now we continue it, because so what we did, we gave a sinusoidal three-phase supply, we got a sinusoidal three-phase flux actually, and this three-phase flux is given by this three-phase equation. Now you know what do I do is I keep omega t is equal to 0 degrees. All of you can just observe here 0 degrees once, and I observe the equations. Later I go to 60 degrees, observe the equations. Later I go to 120 degrees, observe the equations. Later I go to 140 degrees and write up the equations and try to observe them actually. So let us continue with the explanation of 0 degrees. When I keep 0 degrees, sine 0 minus 120, sine 0 minus 240. All of you know sine 0 is equal to 0, sine minus 120 is minus root 3 by 2 into phi m, and sine 240 degrees is root 3 by 2 into phi m, where root 3 by 2 is 0.866. So these are the three values, out of which one is 0, one is minus 0.866 phi m, and the other one is plus 0.866 times of phi m. So these values are written like this. One is a positive value, the other one is a negative value. Now we apply a parallelogram law and we get the total flux. So phi t. So when I apply the parallelogram law, so here r is 0, phi y square plus phi b square plus 2 into phi y into phi b into cos of the angle between them. So you can see here phi y, phi b, 2 into phi y into phi b into cos theta. Phi y, phi b are phi's, all are phi's here, phi square plus 2 phi square into cos theta. Phi square plus phi square becomes 2 phi square. So 2 phi square comes out. So it becomes root 2 phi into square root of 1 plus cos theta. What is 1 plus cos theta according to trigonometry? 1 plus cos theta is cos square theta divided by 2. So here, you know, theta is 120 degrees. So here you can see, so theta is 60 degrees, which I write here. You can see 30, 30, 60 degrees. So 60 degrees divided by 2. So it becomes, so you can see 2 phi into cos theta divided by 2. What is your phi value? Actually, it is the magnitude of 0.866 times of phi m. Cos 30 degrees is also 0.8666. So root 3 by 2, it becomes, so it becomes 3 by 4. And in the numerator, you have 2. So it becomes 3 by 2. 3 by 2 is 1.5 times of phi m. So that is how you are going. This value, whenever you keep 0, the final total value of the flux is 1.5 times of phi m. Now I go with 60 degrees. When I keep 60 degrees here, when I keep 60 degrees here, when I keep 60 degrees here. Sine 60, root 3 by 2. Sine 60 minus 120 minus 60 minus root 3 by 2 are 0.866 times of phi m. Sine 60 minus 120, 180 degrees, sine pi is equal to 0. Here also you can observe, and previously also you can observe, one value is 0, one value is 0.866 phi m. The other value is minus 0.866 times of phi m. So here also you can see one value is 0, the other one value is 0.866 times of Im, the other one value is minus 0.866 times of Im. Again, so here you can see from flat surface it has moved up. So here you can see again the phi t becomes the same formula which we have discussed before. So 2 phi into cos theta by 2. Phi is again 0.866 times of phi m, and theta becomes 60 degrees, cos 30 is 0.866. This 0.866 and 0.866, they are multiplied with each other and they become 3 by 4. But 2 is there in the numerator. So 2 into 3 by 4 becomes 3 by 2. 3 by 2 is called as 1.5 times of phi m. Here also you get the value of 1.5 times of phi m. So we did with 0 degrees, we did with 60 degrees. Now we are going to check with 120 degrees, all of you. Sine 120, sine 120 minus 120, sine 120 minus 340. Sine 120 is this value. Sine 120 minus 120 is 0. Sine 120 minus 240 is minus sine 120 minus 0.866 times of phi. Again, you got a 0.8 plus 0.866 times of phi m value. You got a minus 0.866 times phi m value. You got another value which is 0. So what is the parallelogram equivalent of these values? The parallelogram equivalent of these values is, again we have discussed, it is 1.5 times of phi m. You can see the phasor diagram. The first one was like this. The second one was like this. The third one moved away, and the fourth one. So we are going with the fourth one, which is 180 degrees. So whenever omega t is equal to sine 180 degrees, 180 minus 120, 180 minus 240, sine n pi is equal to 0. This is positive value, this is negative value. The vector equivalent of these two values is 1.5 times of phi m. So what did you observe? When the angle keeps on changing, the total flux is always the constant, 1.5 times of phi m. But the angle is changing actually. So this is how it is being represented. So you have a flux one side here, you have flux, you can see here, the flux comes down, the flux is rotating like this. The flux is rotating. So the flux will be rotating. So here it is at green, later it comes to blue, later it comes to red, again it goes to green, again to blue, again to red. So you can see it is constant in magnitude but rotating in nature. So that's all about rotating magnetic field theory. So the magnetic field is rotating with a speed. Actually, that speed is called as synchronous speed. The magnetic field keeps on rotating very fast. That speed is called as synchronous speed, and it is given by ns, and it is rotating in nature, but it is constant. All of you can see here 1.5 times of phi m at 180 degrees, 1.5 times of phi m at 120 degrees, and 60 degrees it is 1.5 times of phi m. At 0 degrees also it is 1.5 times of phi m. So it is constant. 1.5 times of phi m is a constant value, but it is rotating with a speed. That speed is called as synchronous speed. So this is all about the rotating magnetic field theory, and it is very important to understand the next topic called the working principle of three-phase induction motor. So thank you very much, all of you. Hope you understood this one. If you have any questions, you can just keep it in the comment box. Thank you, all of you.